Once again, welcome. Welcome to this August UniPhi webinar on artificial intelligence UniPhi style. Okay. If anyone can't hear me, I'll see the opening slide that just says AI UniPhi style. If someone can give me a thumbs up that they can see all that. Awesome. Thank you. So let's get into it. First, what I'm going to do is I'm going to cover just a background to AI itself. I asked our dev team some thoughts on some stuff yesterday and was interested in some of the things I'd been reading that hadn't crossed their desk yet. So I think it's always worth getting different people's understandings of something, and you can hear mine and correct me if I'm wrong, either in the chat or after the meeting. But this is where I'm seeing AI going and the sort of way it sits in the marketplace. And then I'm going to take you through how we're leveraging some of the tools and libraries that are available now to start to build our own AI capability in the application. Now, there's a fair bit of debate as to whether UniPhi already has AI elements. It certainly has machine learning algorithms. I would suggest it probably stays there. So to start things, we really need to start talking about what is AI and what are the requirements, more importantly, to being able to successfully develop AI within any product, within any application, both hardware and software-based applications. So in this, all blokes, when they try to communicate a concept, always use a pyramid, so apologies for that. But in this pyramid, what we're saying is that the foundation element of any AI application is large data sets. And so I guess what we're trying to present there for you guys as a heads up is when I get into the UniPhi elements of this webinar, you're going to need to think about how you can capture larger and larger amounts of information into the application. That's going to be key for you to be able to then use the algorithms that we're building and the generative applications that will leverage off those algorithms. So once you start, and I'm going to talk about ways of doing that, not just within UniPhi, but other applications that are doing it, and the sort of scale that you need to get this AI to work successfully. I think that's going to be the key thing for our user base to start looking at expanding what they're doing and capturing more information. So large data sets, you're going to see me bang on a bit about that throughout the webinar. Then obviously there's software development algorithms written to read those large data sets, and they can be very broad. Generally speaking, one of the main training algorithms is to train the application to be able to think for itself. That's where the AI element comes through. That's where the bits that don't really exist in UniPhi at the moment. And so to give you an example, if you were to have an application identify an apple or a banana without you telling it what an apple or a banana is, one way to do it would be for that engine to have seen an apple labeled as an apple and a banana labeled as a banana a million times. And once it starts to get that repetition into its algorithm, it'll start to recognize independently when a new image appears in front of it, or the text is APPLE, etc. So, there's an example there. About 1 million images would start to get that algorithm to start to work. So it's the sort of size of the data set that you're going to need. Other AI tools do different methodologies that don't require perhaps on such large data sets, but on more structured data. And so they're known as things like mutated algorithms, where they leverage off learning from one algorithm to generate their own. They're self-generating. And others are just simple rules-based systems. And so to parallel that in UniPhi, what you would see there is our red, amber, green statusing. The red, amber, green statusing in UniPhi is internal and external metrics around a project's success, but they're not controlled by the end user. They're rules-based algorithms in UniPhi where the computer is analyzing the data across a series of metrics. Each individual metric has its own red, amber, green statusing based on the rules, and then that aggregates up to an overall rule for the project. And so I'd say that is a machine learning based methodology. So those rules can be improved over time by the algorithm and get more accurate based on learning, but they're still set around some structures like, a budget being, an actual being over budget is not what you want from a project. So that rule is known to the application, it's been written by a developer, it's known, it's not something they've learned, they've been told that specifically in the code. When you've got these algorithms working on large data sets, then you're able to start to develop the new part of AI that's coming out now in different applications that I'll show you in a minute. And they're called generative applications. And what that means is that they can actually generate new content. And so you would have heard about possibly about image and graphics capabilities from AI, where it can generate its own images of things that people are saying are quite impressive. You would have heard about ChatGPT, where it generates its own text-based response to any question you ask it, and you can have, as the term sort of implies, a conversation with it. And so these are massively leap forwards from what we had before, where rules-based systems needed to be in there. That there are no rules in the system, it's just training on very, very large data sets, and it's learning inferences and nuance and causality between those data sets. Those statistical algorithms are enabling the engine to learn on its own. And that's the big leap forward, because then you can have, you're not constrained in your outcomes. So our system is constrained at the moment to the metrics that we track for a project and the rules-based systems we put into that. Over time, that shouldn't really matter. The system should be able to generate its own learnings over time to tell you what's likely to go right or wrong on a particular issue or on a particular project. So the sort of popular one to demonstrate all this on, and luckily for us on Friday, there was a massive update to this. I've had this graphic for a while now, but it really does demonstrate what we're talking about. And I see huge parallels to what we're trying to do at UniPhi in this sort of full self-driving projects, if you like. But what happened on Friday was that Elon Musk, is like in my head, he's got some impressive companies out there. He drove around in a Model S full self-driving version 12. And this was a complete rewrite of this full self-driving, whether you think he should be able to call it that or not, full self-driving software. And so therefore had no link to version 11 and the versions prior. And what it did was it transitioned from a rule-based system to being a system purely learning from watching. And so their core application has watched millions of hours of videos of people driving cars. So a Tesla has 8 cameras positioned on it in various places on the car. And that is transferred back to a central processing unit. They've just upgraded this processing unit with 10,000 graphic processing units from NVIDIA, which is one of the reasons NVIDIA's stock price is crazy at the moment. And that processing of all of that video is teaching the car, similar to what I was saying before about what's an apple and what's an orange. So there's nothing in the application that's saying you need to drive between lines on multi-lane highways, that you need to drive on the left or the right-hand side of the road. And stop at a red light. It just knows that by having watched millions and millions of hours of video. And so that's an example of a generative AI that's evolved and trained itself on hours and hours and hours and hours of video. And so again, emphasizing that we need that hours and hours of video. Now, Tesla's not alone in this chase to leverage AI for fantastic applications. And Google has a new product out at the moment in sort of test for you to play around with. You can still register and get access to it, but it's not just search up a URL and do it. I don't have access to it as yet, so I can't do a full demonstration, but this is the concept that they've got in future of search. So at the moment, they're already bringing in a little bit of generative content when you do a generic search at the moment. Instead of just giving you links directly to the data that they're using and that they're ripping off for their AI, so that you actually go to that website to learn about something, it will give you the answers. So you can, it'll say, what is the population of Australia? There'll be an answer sitting there straight as soon as you see it, that it's answering back as if it's not linked to another website. So that's generated itself on the fly. And in this, it's going further, where it's saying that you can do compound questioning. So the question in this example is, what's better for a family with kids under 3 and a dog, Bryson Canyon or Arches National Parks? And then it's going to give you a response to that and explain, the pros and cons of both options for you then to make a decision. And because it's trying to do interactive conversation, you'll see at the bottom of this screen, it says, ask a follow-up, how long to, and it gives suggestions, how long to spend, how many days do you need, that type of thing. So you can then interact with the system and start to get more and more detail about this potential trip that you're looking to take. So that is, again, using large data set being Google's indexing of the entire internet. And by indexing the entire internet, it has this database of knowledge that it's now using to train the AI using large language models, LLM being the acronym, to then spit this stuff out. A little bit, interesting about who owns the IP to all of that content. But in UniPhi, the difference will be we don't share clients' data. So you'll be able to use the AI in UniPhi, leveraging your own data to represent your clients and present to your clients in a better way. And so if you get a lot of information coming into the tool, even now with the Power BI data analytics that you can perform, that's your data. All UniPhi is doing is enabling you to leverage that information, putting it into a structure that you can perform well on. I've got one more anecdote before I get into UniPhi specifics around this stuff, but I'm just trying to hope I clarify exactly what we're talking about when we talk about AI, because there's a lot of buzzwords out there and a lot of stuff being talked about that isn't really, or it's kind of advanced machine learning or just a good bit of coding. But this stuff is real transformative if we can get it right. And so this is another application that I think we'll bring into UniPhi as something you can use in the future, in the not too distant future. So probably everyone's already heard of ChatGPT. I'm going to give you a bit of an anecdote here. Hopefully it's not too indulgent. It's about my wife. She is not a native English speaker. She has a doctorate in art history. And when writing her thesis, her ability to research, because she can understand, I wouldn't say fluently talk, but can understand 4 languages, she was able to get archival research across multitude of places. And then what her skill is able to join dots and come up with new concepts, kind of like generative AI does. So humans have been doing it for millennia. And joining these dots together, she came up with some interesting stuff. So to extend the anecdote further, one of the interesting things she discovered, she had to join a lot of dots to get to this, is that her studies were on 18th and 19th century history, garden history. And in the late 18th century, the English were trying to both threaten and court Russia. And one of the things they did was they sent to a princess who was future queen of the country, married to the future Tsar, a numerous number of plants. But in one of the plants that they sent, which were all going to survive in St. Petersburg, believe it or not, one of the plants they sent was New Zealand flax. And what they were basically communicating through this subtly was, we now, through our empire and imperialism, have got access to this product, this flax plant, that we can turn into rope. And at that point in time, being the dominant naval country, the UK was importing a huge amount of hemp from Russia to put the roping into the boats, into the ships. And so this was a way of saying, we're making ourselves self-sufficient. We won't need you anymore, so you better be on your toes, while also giving someone quite a magnificent gift of 180 plants that were not fully grown, but were grown. They weren't seeds, they were grown, and then teaching them how to keep them in hothouses. These include Banksias and African plants and all these other tropical and crazy looking plants that they'd never seen before. So when she did all of that, she came up with all this great stuff. We talk about it, and then I'd read her thesis, and it was hard work because she was writing in a language that was her second language. And so I had to work with her throughout that PhD program to rework it and to get it to edited and actually pass muster for a doctorate. She got that, fantastic. She's out in the world now. She's a lecturer at various universities, and she likes to tweet about the publications that she writes. And prior to ChatGPT, she would come to me with a tweet. I'd be working on something, and suddenly I'd be having a laptop shoved in front of me and saying, "Does that read okay?" Then ChatGPT comes along, and she starts to use that. And she's probably the guru in ChatGPT. And so she's now tweeting every day. I never see any of her tweets. I read them when they come through on my feed, and I chat to her about it. So it's moved from being an editing function to more of a conversation function around the topic, and cheekily questioning whether the drawing of the bow has been accurate or not. But I just think that that's an amazing thing, an amazing productivity improver, an amazing transformation that we can apply. Just to give you a sense of that, hang on a sec, I've just got to find it. Here we go. Bring this across here. So what we have here is ChatGPT. So I don't know if everyone's logged into it before or not, but I actually only registered today to test out this stuff that she's been telling me. I've seen her do it herself, so I've seen the interface. And when we first did it, my son is also presenting today. He has a presentation at his school, and he's doing it on why ducks make great pets. So I just copy pasted one of his palm cards into the system. So this was it here, and I instructed it what to do. So just like full self-driving, you still need to tell the car where you want to go to grandma's, go to the doctor's, whatever. So we're telling it what to do here. So it's rewrite this as a tweet. And this was what he had on his palm card, just word for word, 9-year-olds writing, no edits or nothing. It says, okay, then ducks are not aggressive, able to adapt to any weather, and are great for your lawn. Ducks are highly sociable birds and they get along with each other. And this is what it came up with. Ducks, non-aggressive and adaptable in all weather, perfect for your lawn. They're sociable birds that coexist harmoniously, and then put some hashtags in there. So then I said, okay, that's great, but now write it in use New York Times style. And it goes, in a world where aggression takes a back seat, ducks emerge as adaptable wonders, effortlessly navigating diverse climates. Beyond enhancing lawns, their innate sociability fosters seamless camaraderie. Discover their harmonious existence of these avian companions, right? And then I did what she does a lot, is to say, tone down your response. So you're having this conversation with someone to give you the answer you want. It was funny when we said tone down your response, it ended up coming back almost to the original one. So I found that interesting. So the idea here is in UniPhi, we capture a huge amount of text-based content. And I'll show you some of that later. We can definitely improve that content through these types of tools. That's all of the anecdotes now, guys. Appreciate the indulgence. Okay, so now we're going to look at UniPhi and how this relates. And so the first slide I'm going to show you is our classic integration, one application to rule them all slide. So what UniPhi brings to the table is an architecture that makes sure that your data is structured. So that will reduce the amount of data required for the system to learn, because we can merge and blend a rules-based system with a training-based system. And pick different libraries to do different things. So in the UniPhi architecture, we have interfaces to capture everything that's in the Venn diagram in the center as our own interface, or we can plug it into other applications through our REST API if you're still wanting to use those applications instead. And so whichever way you go, mix and match, you're going to have this data coming into UniPhi that's got in-field data from photos and issues and safety issues and defects, etc. Risks, documents, including drawings, project owned value, contract administration instructions, other collaboration, RFI management, contacts databases, roles and responsibilities around those contacts, unbelievable large volumes of structured data around what happened on this project. Equally, you can pull in other data that you've got from other applications out of the box. We're not generally an estimating platform, but we can pull data in from estimating platforms. Emails, plugging emails into the product is simple through the add-in in Outlook. And now you're getting even richer commentary around an issue, around an RFI, a defect, a design related conversation. And the thing about UniPhi is it's not just text-based data and image-based data through surveillances and photos, but also numeric-based information. And so you have budgets and you have timelines and you have timesheet records and actuals and percent progress on contracts. So we can combine text and numbers to validate and drive the learning of the system. So what that does for us is it starts to demonstrate how you can grow data quickly. So what I'm going to do now is just jump into the UniPhi application. Here we go. So this is major projects. This is a dummy demonstration system. And I just wanted to sort of demonstrate a few things that emphasize my point. So if I go into the issues system and we click on an issue here, this equipment didn't arrive. It's already known that it's a time-related delay, that it relates to this project or activity, depending on how you've structured this breakdown structure here. And we know who's assigned to, we know what role they are because you can inherit that from the resources. We know what company they belong to. We know what site they're located at. We have actions with other people resolving them. We have a whole heap of other metadata that we can capture against it. We then can link documentation to the system and emails. And so we're now getting the richness of the words that are describing what this issue was all about and how we went about resolving it. And so, this is a massive set of data just in one issue. You start to log these every day, you will rapidly grow out the ability to have a large data set to start to train UniPhi's AI applications on. The next one, so that's the issues module, is in the documents module. And if I go to surveillance record template, we have some projects in the field now that it got up to 60, 80 people looking at surveillance records on roads and rail infrastructure projects and capturing surveillance records that includes photos on a daily basis. And so when they do that, it has a whole heap of information around it: the date, the activity, the what was being audited, any related issues that came out of it, and photos. Apologies, I thought I was clicking on one that had photos, but let myself down there. Even just be this one, second one. And so this one's filled in better. And so there's the related issue, there's the photos. And when you do photos, again, you get even more metadata because it's stripping out the location of that photo. This activity would have chainage, a whole heap of road-based information or rail-based information around it. Getting those coming in every day, we can start to train the system on the images. If there's common defects across projects, I'm thinking more in commercial towers, this would be applicable, but maybe on concrete pours on roads as well. And you get similar photos being taken of different types of pours. It can give you similar results, similar concrete test results, similar resolution results that they came up with to solve that problem. So issues and documents are generating voluminous amounts of information. As part of UniPhi 20, we're building a subnav in documents to develop and design out drawing register collaboration. In that, we'll be stripping out the DWG metadata as well. So revision numbers and design collaboration conversations. And so through that, we'll be able to bring that into the AI conversation as well as take out a few of our competitors. So drawing information, photos, and conversations. Then, of course, we've got all of the financial related information as well. So we've got a budget, we've got metrics around that budget, we've got cash flow budget, we've got actuals. Someone asked the other day, my budget doesn't equal the report. And I was like, which budget? There's 7 types of budgets in UniPhi. There's resource plan budgets, there's a whole of project budget, there's a life cycle phase budget, there's a cash flow phase budget. There's a whole heap of different ways of applying budgets to the system. So that context is known by the way you put it in. We know this is a cash flow budget, for example. We know actuals, we know forecasts. And so again, we can correlate the way they change with the issues that are being raised and with the conversations that are happening in the issues module. Similarly with contracts, we know how many variations were raised against it. We know the valuation, we know what issues led to those variations. We know which contractor was involved, which architect, all that sort of stuff. So this multifaceted model, multi-matrix, one person said 3D to me the other day, it's multi-matrix. It's almost, the true matrix, and we're sitting somewhere in between, is what you can capture if you're using all of the functions on a daily basis across your project environment in UniPhi. So that's where the data starts to come in. If we go back to our presentation now, look at the next slides. What does that add up to? So if we look at a very simple 10 user deployment, if they were logging in 10 comments per day, so not 10 issues, but 10 comments, because you can append and write comments against an existing issue, including emails. So they might be saving emails against an issue or saving emails into the document system. That's 100 database-wide transactions just there and then, which is 36,500 per year. Now, we really want to look at millions to get AI training, so we're not quite there yet, but hang on and hold your hats. Obviously, you increase that user count, you get a team with 100 users. you're instantly increasing that. And we have, some user bases that are between the 600 and 1,000. They're not all in the system every day doing this, but if they were, you were talking about an enormous amount of systems data collection, which isn't easy to do if you've got a whole heap of other systems. You need to build data lakes, you need to clean the data as it comes in, you need to work out, you can't correlate a spreadsheet to a SharePoint list to something else and understand they're all on the one project and the metadata that exists around that project. It's a far more complicated project. With UniPhi, it just happens by using the product. So I showed you the surveillance documents. Again, you had 10 of those per day and you took 5 photos per surveillance, which tends to be the average. You got 50 database transactions just in that element per day, and that's 18,000 a year, and 100 is 182,000. And then if you've got timesheet entries, you've got 10 people timesheeting, they put in 2 records per day, let's say. So that's 2 tasks they've worked on. Most people maybe would do less, but then they write comments against it, totals up to 20 words. You've got, if you're looking at the words combination, you've got 146,000 data points there. And that'll link to this next slide where I'm going to show you how the metadata starts to add up in terms of database size. Similar to the 100, increase the factor. Now, when you wrap around all the information you know about a core transactional data, like a timesheet, like an issue comment, like a risk, you've got so much more information. You know who logged it, you know who responded to it, you know what role they're in, you know what company they're in, you know what the budget was for that project, what sector it was in, what project type, etc., etc., etc. You actually start to get, $3.6 million, that's 3.6 million data points just wrapped around those issues that we saw before were only 14,000 transactions in the database initially. But in terms of the matrix, you've got 3.6 million data points to analyze. And if you've got 100 users, you're looking at 1,000 pieces of metadata per issue and 1,000 per day. And the database points is now 1 million and 365 million data points to analyze per year. So we very rapidly got above the million. And similar with words, you can actually strip the words out of a comment and start to analyze them. That's how you do sentiment analysis, and that will be coming into UniPhi to understand whether an issue is being positively addressed or negatively addressed, and if people have got tendencies to be critical, that type of stuff is going to be possible. And so easily you can see sentiment, because if you're doing 100 words per comment, which isn't hard when you're getting emails into the system, that's 365,000 words per year and 365 million in a larger database. So it doesn't take much of a deployment to start getting information you can use from an AI context. So let's have a look at what that means. First, I'll show you some screenshots of some potential interfaces and what they'll do. These are the less exciting ones, and then I'll use the interface as well to describe some more daunting challenges that we're going to face down the line. Have a couple of the developers on the call today just to scare them a little bit, and we'll see how we go. Because obviously this stuff isn't the easiest to code up, but this stuff we're about to show now is definitely doable, and I'll give you the timeline for when we want to be able to do it. So at the moment, we already have quite easy ways of analyzing your data through Power BI. And this is an example of what I'm talking about with metadata. You've got sector, project type, and location description. You've got gross floor area. You've got a link to project pages when you highlight a project, but this is actually a range of data points, right? Wouldn't be a million, but it's a range of data points to show you the price per square meter of floor area for different types of things on a building. The consultant fees, the finishes, the fittings, the substructure, the superstructure. It's called a box and whiskers diagram. And it tends to show you can see where your project fits within that, and you can start to have conversations. Is that because of design? What's driving cheap or expensive or average result on those lines? It can also be great for QA, testing outliers and see that there's something wrong with the tender or to the estimate. UniPhi also has a machine learning cash flow algorithm. It trains itself on past projects. And so if you've got similar projects in the system, the progress claiming, if you're doing contract administration, your progress claiming, we know the progress profile of those projects because the percent complete was entered into the system. We know it by our trade if the QS is tracking the trades. So there's a very rich data source there for us to train and develop new cash flow algorithms. So you then go and consult with a property developer and you say to them, this is the cash flow drawdown that you're going to need funding for an $80 million commercial tower. And you know that it's going to be very accurate because it's based on the productivity profile of, say, you don't need a lot of projects. We've tested this. You need maybe 5 to 7 projects to get that cash flow. But it's a rules-based system. It's not a machine learning one. It's not a true sort of predictive thing. It's using rules-based algorithm. We're looking to make that a mutated algorithm where it'll automatically determine the timeline as well. At the moment, you need to put in the timeline. That'll be a change coming where it'll say it'll take 18 months and it'll take this kind of cost profile. And if you've already done the predictive estimate, which we're building as well, the parametric estimate, then that'll feed into that. So parametric estimates of how many, the floor area and the floor to wall ratio and all these other things will go into the parametric estimate. That'll feed into the cash flow profile and the timeline that you can present back to the developer and say, here's what you need to take to your bank. And I mentioned already, we've got the libraries that are available to us for sentiment analysis, and we could flag these are issues. Each line there is an issue description, and it gets a positive, negative, or neutral rating. And if you've been on other webinars, you would have heard that when we did this, we just ran it on people's comments in our own application that we call dog food. And it turns out I was the grumpiest person in the business. So that was an interesting insight. I use lots of happy faces now. And so, yeah, the uses of this mainly will be around, being able to see an issue that might be trending offline from a high level perspective, rather than having to drill into everything. What I mean by trending offline is it's not getting resolved. There's lots of more and more stress comments being added to the issue. So that stuff already exists, and we can incorporate that into the system. Then we need to compound these things, bring them all together so that when you start a new project, you can ask it, once you've given it some parameters, to advise you of similar projects. So this is, again, a rule-based machine learning algorithm. It's not generating new content. It's just showing you stuff that exists, except for the confidence level. So the confidence level will be saying how likely we are that that is correct. I don't know, you would have seen that in football matches these days. The game's 5 minutes old and they're already telling you what the percentage probability of each team winning or drawing is. And so you might not even need to watch the game anymore. So this is what this screen is doing. These are all past projects listed there, the 5 projects. They're showing you a confidence level, what their cost profile was, what their duration was. And those icons on the right are able to go and see additional information around their timeline, their expenses, and the risks that they face. We'll have more information to give you some idea around on hover, and the ability to, with those little arrows, expand and see additional information like the functional units, start and finish data, lifecycle phases, etc. Then, as I mentioned, you'll be able to start to generate budgets. Again, at the moment, it'll be a parametric modeling. Our goal will be to get it to be just learning. It'll just learn. It'll use multi-factor to determine what the budget is, rather than just a parametric parameter and lots of projects to train it on for benchmarking. But we're good at that, and we've already done that before. So UniPhi 20 will have the ability to create a budget based off other budgets. When you do the cash flow in the system now, if you wanted to see that, if you do a benchmark cash flow, that's the cash flow I was talking about before that already exists. It asks you which projects to use for that. In the future, you shouldn't need to do that. The system will probably be better at telling you which ones to use than you will be. Same with creating a schedule. And then further down into the project, you can start to see, once more metadata and more information is available, the system able to tell you, and this is where it starts to get a bit generative. At first, we were just looking at it like a search return results, where it just shows you issues that affected completion of other projects. And this one here is saying, okay, this project's finished. These were the issues that affected completion, but it's actually a generative response. It's not the specific issues. You can see it then says view the specific issues, and that'll take you to the issue system, and you can see those issues that affected completion that it's used to generate the algorithm. But typically, because of the volume of data, it'll be more generic across all projects for this commercial infrastructure commercial tower of 40 floors or something. These are the issues that affect completion more than not. And that's the drill through to the specific issues that are listed there. And then when you do log issues on the job, so you're going through design or you're going into post-contract and you're getting RFIs, you can see whether there've been similar RFIs resolved in the past across your UniPhi deployment. So there's some deployments where this is going to set up really well. We have a roads program in Sydney that had a lot of projects, smallish projects, but all over the Sydney network. So you think of that Tesla diagram all over the Sydney network, cars driving. This had projects, lots of project managers. They're not necessarily going to know what each other's doing. UniPhi had that information, but it wasn't able to present that to them in any easy way. So the idea is that here is you can add an issue and just say, how has this been solved elsewhere? And it'll give you that information. Who was involved? What was the resolution? How long did it take? And where was that issue? And you can go and have a look at it and see if it's applicable. Yep. So that's some screenshots of actual interfaces. That may change dramatically as we roll them out, but that's some ideas of design that we've got so far. Other ones that haven't been screenshotted yet, I'll bring up through the interface. So you saw the ChatGPT interface. So the first example of that, well, actually taking a step back, what we're first doing is rewriting the search. So there's a search box at the top of every screen. And when you're using that at the moment, it's okay, but it's not as good as it should be. And so the rewrite of that is using a much more sophisticated Bayesian search logic that, Bayesian was the first type of logic that was used to identify spam in emails. So computer machine learning to identify words and things that link to spam. This will be words that will link to similar issues, to similar risks, so that when they're doing searches, you can then use the search function to find that. And the way it'll be addressed is similar to in communication. So communication is an integration module. It has, comments, documents, emails, issues, and risks, all in the system. Through documents, you have access to project management plans, which had budgets and timelines in them. And so this pool of information, this pool of records that you see coming down here, which is only 1 month. So if I go all, you have pages and pages and pages of that. So you can see we've got 10 pages plus ... to all. And of course, I'm only looking at open projects, not completed ones. When you hit search, it'll search the entire database and come back in an interface similar to this, or similar to what you're used to when you search for Google search or something like that, where it describes what it is you're seeing. So that, unlike this, there'll be a little bit more text about what this document is sitting underneath it, and then you can click and see the document. Still not generative, it's just giving you the results back, but it's going to be a lot more helpful for people to find information and find lessons learned on other projects and things like that. Then what we need to start to look at is develop conversational search. So conversational search is like the ChatGPT. And so I see the application of that coming through in the issues module, similar to how I described the tweets or the X's, if that's what they're called these days, that my wife does, where you would come in here and instead of clicking add and writing the issue description, you would go into the interface for the conversation, and you would say explain, and then you would write what you think the issue is. Some of the things that I expect we should be able to do, like if someone was to ask us that question about budget, we should be able to know with a little bit more information, like what project it was on, pretty much is all we need, and whether it was what type of budget it was. We could know what chart of accounts captured that budget. We'd know whether it's an approved or original and what the transfers were. And so there's a lot of information we can already know to write the description better so that people who read the issue are better informed. What we see is issues having 2 or 3 or 4 conversations back and forth to clarify. So an RFI might be raised, and the first response is, can you clarify? And then an RFI gets closed out and another one comes in sometimes. But if you append it to the existing RFI, at least you get the history. And so this conversation goes back and forth for maybe 2 or 3 days before you actually start to try and solve the problem, because the communication hasn't been that great. So if we can use these ChatGPT tools to drive better descriptions, more thorough descriptions, more accurate descriptions of the problem, encourage people to think about describing the issue better, we're going to have a far more reduced timeline for resolving issues. You reduce the timeline for resolving issues, the knock-on effect should be quite significant. So going into the issues screen and talking to the issues module about how to describe an issue is something we can definitely deliver in a relatively recent time. Equally, should be able to go to the contracts module, and instead of just adding a new contract, we should be able to say, who should I use as an arborist? So come in here, type give me 3 arborists for this project. And it would return 3 arborist companies with contact details and the last 3 contracts you did with them, for example. Now you need to be capturing your information in UniPhi and putting people into the role arborist, into the role mechanical engineer, into the role that they're in, so that information is known. Otherwise, the system's not going to be able to train itself. But this is the type of interaction we're expecting you to have once you get that quality of information into the application. Another one that we see coming is the ability to come in here. And so we had that early stage budget you saw from the beginning, create budget, but we should be able to get to a stage where we use generative AI to come into here and use the other design metrics that you've put into the product, the other metadata and similar projects to say, build my budget. And so you would come in here, you click a button, build my budget, and it fills in. And so to put that into context, if I just go to this project here, when we get budgets estimates coming in from estimating tools, this is the sort of quality of information we get. It's fantastic. Quantities of of different things, the different elements, rates coming across for that, and then underneath, metrics and benchmark ratios and fence checks. This data can then be used to do the build my budget. And so if you can capture this information first through having tendered prices and either high quality pre-tender estimates potentially, but probably not, into the system, over time, build up enough of the database in similar type projects, then UniPhi should be able to generate the budget on the fly. So rewrite my comment to make it clearer, build my budget, and tell me what contractors to use are 3 examples that should be coming your way in the not too distant future. None of that will be possible if you don't have the data. It's your data. We don't have cars. Tesla relies on their cars being driven around. So I rely on UniPhi being used in all of those modules on a day-to-day basis. Otherwise, there'll be no data there for you to use this type of functionality. And we definitely have projects out in the marketplace right now who have this richness of data, and we'll be working with those organizations to see how our algorithms go in terms of training on that information and using it to give insights. All right, so when's all this going to happen? We plan to, so the way UniPhi works typically is July every year we do a major release. UniPhi 19 was released last month. If you haven't got upgraded yet, please contact us. We can schedule it in. Every single client is their own instance of UniPhi, and so you can sit with that instance if you like for as long as you like, but we do invest heavily in the product, much more than anything else we invest in the business. And so there's always good new stuff coming out. However, there's also people who want things earlier, and you can be on our, we call it the bleeding edge program, because you're willing to try out new stuff that, it's beta testing really. It's not fully productionized yet. So we plan to have that ready for the Bayesian search I mentioned at December this year, so not long away. Isn't that right, Caleb? And we would like to be able to have issues being able to be rewritten and being able to find similar issues and similar projects by March next year. And then that'll all be wrapped up into a 2024 UniPhi 20 release in July, which will also include the estimating, the generate budget, generate schedule information. I don't think we'll be down to the element level. It'll just be a budget at a high level, which you can cash flow at a high level. So it's like a one-liner, if you like. But if you're doing early stage feasibility and working with property developers around that type of stuff, that can be quite handy. And again, there's no real threat here because A, the thing doesn't work if you don't put information in. So you need to be doing what you're doing now on a more broader scale, potentially, for quite some time for it to be able to be trained up. But equally, it just enables you to have more conversation rather than have to do the grunt work. So you can sell advice, sell knowledge, sell sense check, sell consulting services rather than labor services, if you like. And then finally, the aspirational goal is to be able to chat to UniPhi in about 18 months' time.